A very good morning to one and all present here. Take risk in your life. On behalf of Center for Innovation, Incubation and Entrepreneurship, consider it a great honor to welcome our chief guests and keynote speakers, Mr. Pathik Desai and Mr. Abhishek Roy. I heartily welcome you, sir. I also welcome our faculties, Professor Anuja ma'am and Professor Tenzi ma'am. My dear BBL, I welcome you all. Now,
Good morning, everyone present over here. I am Pathik, here to give an introduction on Vivek College of Commerce and Center for Innovation, Incubation and Entrepreneurship. Vivek Education Society is a charitable institution working. Society is set up in year 1961, had established Vivek Vidyalaya in 1962, had followed it up by starting junior college. Vivek College of Commerce has started in year on 11 December 2018. Vivek College of Commerce is first college in Maharashtra to inaugurate an incubation center under MITSC, Maharashtra Information Technology Support Center. We have registered ourselves. Also completed and approved all our quarter 1 and 2 activities. Under IIC, we also have Atal Tinkering Lab schemes in which we do mapping in different schools. We had participated in NEC, National Entrepreneurship Challenge. We in build advanced track, and we were only commerce college amongst 900 plus engineering colleges, and Google have recognized our podcast for selecting it for uploads on their platform. So now let us know about key experience in Atlas Skill Tech University as a visiting faculty. Ripple Effect as product design intern, Maratha Motorcycle lead designer, and many more. His achievements are Tinker Labs, workshop volunteer for design thinking, Maruti Suzuki live project. Abhishek Roy, sir, he has work experience in Duke Technologies as a manager of product design, IDM design, and product design intern, founder of LK Labs Private Limited. What an achievement, sir. Thank you.
Yeah, sorry.
Sorry, we have dogs. They're in the morning, they're very excited.
take over the session.
Sir, you can take over the session now.
Oh, all right. Thank you so much. That was a very kind introduction. Let me just run you through what we do. We're like the let's say the intermediaries between engineering and users. So what usually happens is engineers have very beautiful functional solutions, engineering. There are a lot of beautiful thoughts that come out of engineering which need to be translated into a form that a user can understand, because a user is not at the level of let's say proficiency with let's say functional we understand function, and we understand usability, let's say. And we tend to bridge those gaps. So one of the most obviously, uh, say, usable example that Apple is pretty much like they've built their entire what do you call it? The entire appeal of that brand is the fact that they understand people, right? Like their products are probably not the most advanced in terms of engineering specs, but that are out there that are based on design, and they're reaping the rewards for those. Like Volkswagen is another organization that gets really into. You can move from any Volkswagen Group car to another one, and pretty much all of the So what we are going to explain to you is today is this one key process which helps you realize, that that intermediary stage in between having an idea and having a product that is out there. Pathik, to get started off with explaining to you guys what exactly prototyping is and why it is one of the most important parts of it. Like you must be hearing a lot about things like Make in India and like this push for manufacturing that the government is coming out with. Designing and producing or innovating. And this is a very, very what do you call it? It's a very disappointing thing, because if you look at the biggest companies in the US, they are market cap in automotive. It was Tesla, which was, I mean, the brand was non-existent 15 years ago. So in order for you to become a successful entrepreneur in the US, you have to be an inventor and an innovator and a business that is into product development, or at least in India, you look at the top few companies, they are most likely organizations that do work for the government in the realm of infrastructure and stuff like that. And you know how terrible that the area is, because I'm sure after this to be a small part of that, like a small cog in that entire mechanism that helps people get out there with their own ideas. So, Pathik, why don't you take over and
Yeah, sure. So, okay. Just sharing my screen. Ideally helps you understand the design flaws, understand the market acceptance, understand the proportions of that you're trying to create object. So how a particular object feels in a physical space is why we prototype. Okay. There are four main layers of prototyping. First is mockups, then rapid prototyping, then beta prototyping and alpha prototyping. So what happens is you start with a very, very quick on paper, a quick mock-up, maybe you 3D print it, maybe you quickly get it laser cut, or like, make it with paper. and then you go on to exploring its form and styling. Maybe it's a scale model, maybe it's a proportional model. Okay, so and then you eventually move to creating a beta prototype, which is where you actually test out all the technical aspects of the product. And then maybe you add a body to it, a face or a shell to a product, which is like, which either is aesthetic or usually has a functional thing. So as designers, we always follow a principle called form follows function. So like nothing is in the air, we create everything which is having a reason. So like, let's say if there is a curve on your car, it's actually so where does prototyping come in product development stage? So what happens is prototyping is a third phase. There are two more stages before prototyping, which is finding opportunities, basically your market research, user research, and narrowing down from all those briefs. You create a bunch of ideas, and then you select a certain few concepts that you want to test out. Basically, you want to prototype. So let's say um, based on your user testing, you have about 10 opportunity areas, okay, that came out from your research. You will select those 10 ideas, maybe narrow down to 3 or 5, depending on how valuable your ideas are related to the user. And then on those ideas, you quickly create mock-ups. Like the phases I showed you all earlier for prototyping, you quickly create mock-ups, and then you do the whole rapid prototyping, alpha prototyping, beta prototyping, okay? Then what happens is when you're creating prototypes, you usually need, because the idea has been in your head for a while. So then prototyping actually brings you back to the reality. So there is little to and fro that happens between these two stages. Then after the prototype is done, you do user testing with your target users, and sometimes even your stakeholders that you're considering, like manufacturers, vendors, engineers, all those stuff. Okay, then what happens is sometimes because of the user's feedback, you feel the product or the prototype basically is unfit for the market. Okay, so then you go back to your other concepts and then evaluate ki maybe this will work, and then the whole process repeats. And then once your, let's say your uh, prototype is accepted by the market, or like initial user testing, then you go into making the first batch of the product. The then then if it has better market acceptance and everything, you go into the whole manufacturing process of it, and then eventually it goes to commercialization. So this is like we've come a really long way from making tools from stones to like making them mechanically, producing them mechanically, to automation, to now it's time where robots are interacting with each other, basically Internet of Things. So we are currently in Industry 4.0. So Industry 4.0, may you will hear a lot of these words very regularly. Additive manufacturing is 3D printing, resin printing, and like where we create objects from ground up. And the traditional method of manufacturing is subtractive manufacturing, where you have a chunk of piece and then you remove it and model it. Then there is augmented reality, where you are seeing digital objects in physical spaces so that you could maybe design them better, or like place them in an environment to see how they look and feel. And then Yeah, like robots are like a very integral part. 3D printer is a robot. Like we interact with these objects almost on daily basis. And then like I said, interaction internet of things, where one object is interacting to others. So let's say now you are in an assembly line, the operator has given some instruction to the robot, and then it will communicate with other robot to get the things more streamlined. And like where you would ideally need 5 people to do this, just 2 robots are doing this on a assembly line. And big data, artificial intelligence, as we have already been seeing effects of it, they're everywhere in the industry, and they're creating a lot of benefits for us to like get things faster and more creatively to the market. Simulation optimization is something which has a uh, very heavy impact on the industry right now, because what happens is you cannot always create expensive things. It just increases your pricing, it increases your budget. So what happens is, with engineers, and we design components that are tested on a digital space. So like there are softwares that do digital simulations of how strong is an object, and like how much heat it takes, thermodynamics, etc., etc. So all these are like industry 4.0, like making like back in the days, getting a product would be a minimum of year or 2 long process. Now we can get it out as soon as a month or so. This is all because of industry 4.0. So who all are involved in product development process? So it's largely business developers, designers, and engineers. So as I've pointed out here, business development, the opportunities usually come from research. Research is involved with like research is usually done by business developers, designers, and then concepts are created by engineers and designers. And prototyping may all three are there, because all three are there to create like what kind of material is going to be tested. And engineers with the technical knowledge, designers with the whole design thing expect to aspect to keep the product very suitable and usable for the user. And like business developers will always be there to you know like align you with the goal of the business, basically, even while prototyping. And then same goes in user testing. And then it is carry forward to manufacture engineers who will do the manufacturing, and business developers do the commercialization. So this is ideally the whole organization structure of a private limited company. So you will always have a MD, managing director on top, then comes CEO, and then there are chief of different like operations, and then they have sub managers, and then they have lead or senior executives, and then they have juniors, and then freshers, basically. So, like all this is done, but like, how do we actually come from getting ideas to action?
uh, design is, or rather the prototyping stage is that what tends to happen is you get a brief that, okay, this is something that we need to create. And what this brief usually entails is, it speaks about an opportunity that's there in the market. It talks about the pain points that the user has. This is all research that has to come beforehand to you. So this is either done by the marketing team or by designers in itself. And based on that input, on what you need to create, a brief is developed with certain goals, that these are the goals that need to be satisfied. So when that happens, the role of the designer is to explore options on how to present solutions, basically. So you have maybe multiple ideas, say 5 or 6 ideas. Let's say if we take an example of a product in the market in India, because of the fact that the Indian automotive market is really strong, we'll stick to automotive. So Mahindra, I think, had just come out with a new variation of the Scorpio. Uh, Before that product is even worked upon, there is a process which they go through, where what you can see on our screen is basically iterations of a new wallet design. So similarly they create multiple iterations. From there, it's like a funnel process where they pick maybe 4 or 5 options, and from those options they test viability of these ideas, and then they further funnel it down into maybe 2 options where 2 teams are very passionate about. Let's say a Bose product will always be gray or something. Now they have a few products which are multicolored, but usually it was always gray and darker gray, and there's Bose written in one point. So that that is a Bose product. So these are many factors that they take into like ideating and shortlisting and selecting a product for further development. So in that sweet spot of innovation is like it's like finding your soulmate. Like at the end of the day, no matter what, you're on a planet where there is probably 3.5 billion prospective suitors, and then you keep funneling down even further based on whether they're your age or not, whether they're in your region or not. And the viability, desirability, and also the market relativity or the relativeness. These are points that you tend to take in. There are a lot of tools that we engage into as well in order to figure out which is the best possible solution, which is the solution that is actually most suitable to the environment that it's in, and what are the different types of failure it could be subject to. Sometimes what tends to happen is you're designing something for children, and everything is perfect till you realize the fact that it's a very heavy product, and one child has flung it at another child and injured them. So you have to take into consideration a lot of these things that can go wrong in the environment in which this product is being used. So is basically one of the as simple as an engineer has developed let's say a pistol grip. You know what a pistol grip is, I hope. So say like for example, for a spray gun to paint, you need a pistol grip. Now if that pistol grip shape is very unergonomic, because of the fact that you need a trigger, you need some other controls on top of it as well. If it is not very ergonomic, it's not good to hold, you can't use that for a long amount of time. You will have some form of pain in your hand, or if the angle at which you're holding it is not right. That's the job of the designer, to come out and figure out what is the ideal method of operation, how the balance of weight should be on this thing, so on and so forth. Earlier, like I would say maybe 100 years ago, it was done by, well, I think over 100 years ago, I think design has been a profession which is slightly older than maybe we would try to give it credit for. Earlier, it was done by engineers, because that was the industrial limitation at that point of time. We had less products, we had less sophisticated manufacturing. Today, you have one design, one CAD file that has to be produced over 1,000,000 times, sometimes even 1,000,000,000 times. So then it comes down to the engineer. The engineer's core purpose is to give that product some form of meaning. So what tends to happen is that we get lost in the beauty of the outside, or the way that you engage with the product, but we tend to, nowadays at least, tend to really not give enough importance to the fact that there is a tremendous amount of blood, sweat, and tears that has gone into making the product reliable. Every time in your phone is in your pocket, but you're 100% confident that say the competency of engineers, along with, of course, developing new solutions to engineering problems. Then we've just called this business expert, but there are a lot of factors that go into it. There are people who are into marketing, there are people who are into business development, there are people who are into sales, because sometimes even the salesperson will come out and say that, listen, we are facing a certain amounts of issues with the product when it comes down to the point of sales, and this is the feedback that we're receiving over there. Or maybe in the US, what happens is products are designed according to Walmart shelves. Like, at least it was to a good extent. So your product, if it doesn't fit on a Walmart shelf, it's not going to sell. And on which shelf you want presence is a very important thing for your product as well. If it's a newer product that you want to do large volumes, it has to take the precedence over there, or it has to have an island of its own. So these are a lot of things that go into basically planning out or projection of how much you can go ahead and sell, dictates the price of sales as well. Because if you say that, okay, I have a million units to sell, and this product is very, 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 very sensitive to economies of scale, then what you need to do is you need to go back to your, let's say your procurement team, and ask them, okay, can we actually save money if we're making 1,000,000 instead of 10,000? So that decides how many orders you need to place. So you need to have the funds for that. You need to have the supply chain ready for that. So it's a very complex process when it comes down to the selling of the product in itself. So this is a very important part of prototyping. What we have very fortunately nowadays is access to 3D printers and stuff like that. But trust me, we are in that way, where they actually sit down and make a mock-up in itself. They have an idea in their head, maybe they don't sketch that well. but they sit down and they develop these products by hand. So you get a very good feel for how that thing would look in three-dimensional space, how it will feel to hold, how it interacts with light. That's a very important thing for you to know, because that could be the difference between something that is tremendously ugly and something that is very beautiful and aesthetically pleasing. Then comes in rapid prototyping. So this is an industry which is, I think I had spoken to this one gentleman who was a part of HAL in the 1980s, and they had got this massive uh, machine which occupied an entire room, and that room had to be climate controlled in order to function. And it was basically a 3D printer. And he would tell me that a lot of these turbines and stuff like that, they would develop on CAD. They would want to prototype them in person. And at that point of time, sometimes if, let's say the climate control didn't work very well, the part would either melt or, it would have some or the other sort of failure before you could actually extract it from the machine and have, like a successful, prototype in front of you. And from there, we've come to a point where, you have uh, 3D printers which are like 10 or 15,000 rupees. And each one of you can actually have one, and there are open libraries across the internet for you to go out and download models and print them and test them out for yourself. Yeah. So rapid prototyping has become like an industry changer in that sense. There are many forms of rapid prototyping. We're just going to talk about CNC and 3D printing really quick. So with materials, but nowadays there have been great advances in 3D printing where you can have almost like a final looking product, or you can have something made in metal as well. Materials like titanium and certain alloys of steel and aluminum are very much possible to prototype from ground up. So we can dive deeper into this if you guys really have questions. But the entire idea of this is that you can actually use rapid prototyping to validate your design before you go ahead and invest in a die or a mold or something like that. And the very interesting thing about this is that we are also looking at these as solutions in the future for manufacturing. Again, like I had mentioned, the brand Apple, they actually CNC manufacture most of their products, like their phones and their tablets and their laptop computers, using CNC manufacturing. So each of them is like a billet of aluminum that they actually cut the shapes out of. So this is a very painful process that we go through, because this kind of can make or break your product. And what tends to happen is ki, everyone comes down to that same point, is ki kitne ka hai, right? Like when you're going and buying a car, kitna mileage deti hai. So similarly over here, what these processes involved is basically costing. So how much does it actually cost to produce your product, and how much does it cost to put it in the hands of your consumer? So there are three sheets that we're going to talk about. There's a lot more that you can get into over here. top right, what do you call it? The top right chart that is there, that's the bill of quantities. So your bill of quantities basically involves the cost of labor that goes into making something. So this is, I think, a BOQ of a building in that sense. So it's basically showing you, the processing labor and the cost involved, the cuts that you have to make, the welds that you have to make, the plaster work that you have to do, the cost of those things. So that is the secondary cost. And then what we have in the last, on the bottom right, the chart is basically your supply chain cost. So supply chain cost pretty much involves, if you have a commodity that you need to manufacture, like let's say your marketing team says, you know what, or your sales team says, we can sell about 1 million of these. So does that help in reducing the cost? And then your production team tells you that, listen, if we produce 1 million of these units, then definitely we can save all this. Or let's say if we can produce 2 million of these units, and you say that you have orders for 1 million right now, then we can save even further costs over there. So you have a demand for 1 million units, you've sold those 1 million units, you have another 1 million units which need to go somewhere, right? So that becomes your warehousing expense. Then it comes to the point of like supplying the product to the warehouse, supplying the product from the warehouse to the retail unit or to the end consumer in itself. This is what your transportation cost would be. The cost of supplying materials to your manufacturing plant also sometimes gets included in that. Then comes in your cost of supplying labor. Do you want to take this, Pathik?
So basically, go-to-market strategy is where now you have a developed product, and now it's time to actually bring it to market, which is why it's called go-to-market strategy, right? So your market is either a new product, new market, same market, new product, or like it's like a new same market but an incremental product, right? So now all these products, all these variables are catered to a certain type of user, a certain type that user has. So what we call them as user archetypes or like persona. So like what happens is all these personas dictate your features of the product, and catering to that you're designing the product, and now using that you've set your color of the product, you've set your um, you know costing of the product, the material of the product. So now what happens is, let's say you do a whole market research of where maybe this particular product has this many archetypes, that is like a sample of about, let's say, a 2.5-3 lakhs of target users. Okay, then eventually you expand it to the market, which is the whole scalability aspect of it. But you want to make sure that at least it's like targeted towards this 2.5 lakh people. And then you create a strategy, like you create a map key. Now how do I get these products to them? So like you basically create like you do user testing with your products, and then you quickly summarizing what all we discussed, there are 5 stages to product development: ideation, opportunities, basically creating opportunities, concept development, selecting ideas from the opportunities, prototyping, creating mock-ups, rapid prototyping, alpha and beta prototypes, and testing them out. So user testing, and then bringing them to production, which is manufacturing, and then bringing it to the point of sales, still like the whole commercialization aspect of it. Business developers, engineers, and designers are one of the key members which you will be collaborating with this in the whole product development process. And you can basically, using this product development process, you can bring any idea to life. There's one thing we say in design is there is no idea that is bad. And like we often use a guideline which is yes and. We never say but and no. We always say yes and. So you always build up on ideas, and then you never know what wild idea you might end up with. So there is never a bad idea. And then do the whole product development process to bring it to the market. And then finally, like, if you have some idea, you feel you want to actually, you're passionate about and you want to get it to the market, go talk to an engineer, designer, or a developer, whoever you want to collaborate with, and then they will make sure that it actually comes to the market. So I hope all this was good and clear, and like we are open.
The limitation of prototypes. Challenges.
So there is a limitation of process, and there is a limitation of the end product in itself. The biggest limitation of the process is that you don't get a very clear idea of whether or not this thing is going to be viable in terms of costing. Sometimes you have to use supplementary materials because you can't, like, for example, in 3D printing, you can't print in the exact same material that you work with in real. You have to work with exemplary materials which has similar properties. That is one part of it. The other issues that you tend to face with prototypes in that sense, because they are the ones who are going to use it in the most extreme scenarios, and you want your products to survive those. So usually what tends to happen is people think, yeah, this is a very expensive prototype, because I've seen some prototypes from very large organizations, and they have like, this is a property of so and so and so and written on it, and it's a crime to remove this out of this, to share pictures of this and all that stuff. So a lot of people tend to get intimidated by stuff like that in itself, and they don't take it to the edge. Whereas we believe in complete destructive testing, so that that this is this gives you a very realistic expectation of where this product will thrive and where it will not, and if it needs to thrive in the environment of what your product is like.
Thank you.
Anything to add to that?
Any other questions?
Sir, a small question from my side. How is it useful in service industry?
I mean, so for example, we have this one product that we are developing ourselves, which is, I mean, it's in the realm of robotics. Your business model is very important. So our business model is that this robot can actually be used in asset management. So for example, let's say if there are cracks on a building and needs to be inspected, or if you need to clean facades and stuff like that, because glass gets very dirty. So in such applications, we feel our product has got a tremendous amount of strength to it.